Alright, trig part. Let's see. So we're looking for secant. Now secant is, now before we even get started on here, right, we might have to do more work, we might be all set. We don't know. But right now we just want to understand that secant is the inverse of cosine. Why? By definition, that's just how it is. It's reciprocal of cosine. So you just have to deal with it. Now, if we're looking from theta, well, here, you know what? I'll tell you what. How about we look at it like this? Since secant is the reciprocal of cosine, now cosine equals a over h. Okay? So secant is h over a. That's all that means. All right. Now, there's benefit to this later on in calculus, but to know that secant is this. I mean, there's all kinds of benefits to it, but the hypotenuse over the adjacent. Now, we are looking from theta here. Now, theta was specifically labeled here in this top corner. So when we look from here, though, we see that that's an O. That's the opposite, and this is the h. Now, we need the h to find secant. We got it right here. But we do need to find the adjacent. So we're going to have to take an extra step. But it's not a big deal because the Pythagorean theorem, what we'll do is we'll just label that a, all right, because for adjacent or for the Pythagorean theorem, and we'll say that a squared plus b squared equals c squared. Now I know that this is the hypotenuse because he's directly across from the 90-degree angle. He has to be the longest side, so in order to form a right triangle. So here we have a squared plus b squared equals c squared. All right, so in my calculator, I'm going to take 17 squared, all right, and I'm going to have to subtract 64 to get a squared. All right, 225. Now, since that's a squared equals 225, a squared equals 225, what I'm going to do is I'm going to take the square root. So the square root of 225 is 15. So it looks like a equals 15. So therefore, if I wanted the secant in its h over a, I want 17 over 15, which is d. All right. Now tangent over here, looking from theta here, we know that tangent is defined as opposite over adjacent. So the opposite in this case is 8, and it's over 16 radical 2. All right, but we do not see this. Well, it looks like there's some simplifications that have happened. So we see that 8 over 16, that's 1/2. All right, I still don't see it over here because I'm not supposed to have a radical sign in the denominator. So I need to multiply both the top and the bottom by that, by radical 2. Now this allows me to get rid of, well, 1 times radical 2 is just radical 2. And in the bottom, it allows me to get rid of this radical because radical 2 times radical 2 is just 2. So 2, remember he's still there. It's, you know what, I'll take a step. How about, that's really what you have. 2 times radical 2 times radical 2 is the same as 2 times radical 4. Now radical 4 is 2. So you have radical 2 over 2. I'm sorry, over 4, because 2 times 2 is 4. All right, and that's A. Okay, so we keep going with this. Let's see, we're looking from theta here. We want cotangent. Now cotangent is actually the reciprocal of tangent. Now tangent is O over A. Okay, so tangent is O over A, so cotangent is A over O, just by definition. So let's look from here. Let's look from theta. That's the O, and this is the A. So it looks like we have both of them. We don't have to use the Pythagorean theorem to figure that out. So we have the A over the O, which is 14, and then we just simplify this fraction. There is no radical in the denominator, so it looks like we have 12 over 14. 2 will go into both of those. So we have 7 in the denominator and 6 radical 2 in the numerator. So it looks like we've got b right there. And then finally sine is o over, oh great. Okay, so this is really convenient because sine from this here, this is the o and this is the h. So it looks like from this, sine is defined as o over h. So therefore I will have 2 radical 13 over 14. And these guys will cancel 1 over 7. So it looks like my final answer is radical 13 over 7. So that's D. All right. What are we at? 5. Okay, I'm going to keep going. 57. Find the measure of each side indicated. All right, so I'm looking for x, and I do have an angle here that's given to me as 69. Now, it would be easy for me to figure out this angle here, but I don't need to. What I'm trying to do here is, if I know that this angle is 69 and I want to find out that, it looks like I'm trying to find out h here. All right, and I do have the side that is actually the adjacent angle. Now, this right here is the opposite, so he's the A. So it looks like I'll be using cosine of 69 degrees equals the adjacent over the hypotenuse. All right. So this is my primary setup, and it's really simple. What I showed you guys is that we either cross multiply or we do a swap. And this is one of the situations where we're going to do a swap. The swap is this. I can move the x in the denominator on this side to the numerator over here, and the numerator over here to the denominator over here. That's just how the equality works. All right. You're basically doing 2 algebra steps. You're multiplying both sides by x, and you're dividing both sides by cosine 69 degrees. So it's you can look at it as just a swap, and that's fine. All right, now we don't have tables, so we will just go ahead and use our calculator. We will go 12 divided by the cosine of 69 degrees. And I'm going to assume, first of all, that I'm in degrees. I am not, so I have to be in degrees for this to work. Okay, so if you have any calculator problems on the test, just remember that the mode, we need to be in degree. Oh, no, not necessarily. There might be some problems that have the degree, that have the angle in radians. So watch out for that. So it's mode. This is how you switch. Mode, radian, degree. Okay, so we're going to go in degrees. We're going to say the 12 divided by the cosine of 69 is actually, I think I hit an extra button. I did. 33.5. Okay, and that is the length. Looks like 57 and 58 did not have multiple choice. All right. Okay, so now we need to look from this angle. We'll call it theta. We are looking for the opposite side because he is opposite from this angle. This is the hypotenuse, so it looks like we will be using sine. We don't care about the adjacent side at all. All right, we don't need that information. So we're going to use the sine of 43.7 degrees equals O, or I'll just call him X, over 12. Now here, the situation is different. This is where I can actually multiply. Okay, I'm going to cross multiply. It's the same thing as multiplying both sides by 12. Okay, you just multiply, cross multiply. So again, it's just that's 12 again, huh? Times the, where are we, sine of 43 point, one more time, 7. All right, so it's 8.3. All right, that's the answer for 58. Okay, we're doing 59 and 60. All right, now we're just supposed to find the value of the trig function. Well, find the value of the trig. Now the cosine here, it looks like they gave us all 3 sides. This is, oh man, this is kind of easy. We already talked about it. It's A over H. Cosine is defined as A over H, so if I'm looking from theta here, okay, the opposite side is 6, the hypotenuse is H, is this 10 over here, and this 8 is the adjacent because it's touching the angle that you are looking from, and O, it is not touching you at all. It's not touching the angle at all. Okay, that's the opposite. So it looks like I just have 8 over 10. And that can be reduced to 4 over 5. So that's D. Moving over to tangent. Tangent is just going to be O over H. So if I'm looking from here, that's O, that's H, that's A, so it's 5 over 13, which is, wait a second. No, I'm sorry. I was thinking of sine. It's O over A, so that's 5 over 12. Let's see. All right, stop here, and then we'll